Okay, so today we're going to take a really brief, quick look here at the scientific method. And basically all the scientific method is, it is a logical way for us to approach problem solving. We use this in science. We want to use it all over the place. In fact, we use it a lot too in the Fab Lab information, and we call it in that case the engineering design process. Pretty much the same thing, just they maybe look a little bit different how they're set up, but they're really following the same steps. And here's just that quick view of what we use as the engineering design process. And this is a really good illustration of the scientific method as well. It's one I really like. We identify our problem. We're going to do some research, brainstorm some ideas, figure out what we want to do. We're going to build something, or in this case, we're going to come up with some type of hypothesis or some type of experiment. We're going to test it, we're going to improve it, and eventually we're going to share it. But that's a little ahead of ourselves. We'll take a look at what we're looking at in this case. Now, for the most part, there's a set of basic steps that we can follow for the scientific method. When I was in school, way back in the day, forever ago, my biology, my physical science teacher, junior high science teacher taught us the 7 steps of the scientific method, and we had to recite those steps in every single test we took every year for those 2 or 3 years. Every single test, we had to do these 7 steps. We're not going to do 7 steps. We're going to have to remember those 7 steps. We want to look at the basic things that you have to do within that. And first thing is that we have to identify the problem. That's the biggest thing. What problem are you trying to solve? What do you need to do in order to solve your problem? What are you trying to find out? If you don't know what you're doing or what problem you're trying to solve, you have nowhere to start from. Okay, once we've identified the problem, then we do a little bit of data collection. We form our hypothesis. What do we think is going to happen? What does it look like is going on? Then we're going to test or experiment with that value to see if our hypothesis is correct or not. And then we're going to do some analyzing our data that we've collected from our experiment and draw conclusions. And we're going to look and see, are we correct? Is our hypothesis correct? We have to go back and make a change and do it again. That's where a retest or revise comes into play. And finally, we have something that we found out, we've backed up our information. Then the most important part of the scientific process is to share our information. And by sharing our information, that's where we're really getting that information out to other people, and that's where someone can take that next step. Maybe something we haven't thought about, they can make a new connection. It's the missing part to the problem they have, or they can take that next step and create something new with that information. So that's really your basic steps to your scientific method that we always want to try and follow along those lines. Now, along with that, we have a couple of key terms that come into play that are laws and theories. We hear about those quite a bit, and I can pretty much guarantee that the ideas you have, what you've been taught about laws and theories in previous classes, is not going to be quite the way I want you to think about them. We'll come back to that word hypothesis too shortly here. But first of all, again, different definition of what you've been used to. If we start with the word theory, for example, I want you to just think about what that definition of the word theory is that you have. And I can almost bet you're going to say something about something that we've proven but not proven enough, something along those lines, because I hear that every year. But really, or a law, then you're going to say is something we've proven enough times. But let's take that a little bit different. Let's approach this and think about a definition that makes more sense and it actually gives you a concrete definition. A law is the behavior that occurs in nature. A one-word definition of a law, and it makes it really simple for us to tell the difference, is a law is what happens. I let go of a pen, it falls. That's a law, the law of gravity. Okay, that's the behavior that's going on. Notice that that's all it is. It's what we see happening in nature. Compare that to then the definition that we're going to use for a theory. A theory is going to be the explanation for why behavior happens, or that one-word definition, why something happens. If you keep track of what and why, that's going to make a really big difference in terms of you figuring out what's happening in this case. Is it a theory? Is it a law? Which way, how do you tell the difference? What happens, law? Why? I dropped the pen, I let go of the pen fell, law, because now I'm talking about the theory part, the explanation. So another common misconception that we say is, can theories become law? People say, yeah, if you prove enough times, it can become law. How many times do you have to prove it? 10, 50, 100, 150? Think about it this way. When can what, or when can why become what? Can an explanation become actual behavior? No. What can't become why, or why can't become what is actually what that should say. Why can't become what. But that's what you're looking at in this case. You can get a good theory, a good explanation, but theories can change. we find new data, we have new experiments that show something else happening or doesn't, that something the theory can't explain, we have to change the theory. And that happens very often in science. Types of data. We'll come back to that. No, we should probably talk about real quick here right away too. Hypothesis, that word hypothesis. The absolute worst definition in the world that I hate is that educated guess definition that you've all been taught many, many, many times. What does that mean? You've gone to college to get an education, so you get to make a guess. The hypothesis got an education? No. A much better definition of hypothesis, and I won't write it here, but I'll just say it and you can write it down, is that it's a prediction of future behavior. That's a really good thing that you want to say in that case. Or another statement you can make is a testable statement, something that you can actually test. A prediction, we can see if it comes true. A testable statement, something we can test. That's a hypothesis, not an educated guess. Get that one out of your mind and don't ever use that one again. Hey, but two types of data we have are qualitative and quantitative. Quantitative very simply means that you have a numerical measurement with it. So you're just going to have a measurement, that's quantitative. Qualitative is just going to be a general term that doesn't involve a quantity. It's going to be something like color or shape, for example. Quantitative, mass, how many kilograms you have. Temperature, what the actual temperature is. It has a number with it, it's quantitative. It doesn't, it's qualitative. And with our experiments too then, experiments are a really important part of the scientific method. We have to have something we're going to test to see if our hypothesis is correct or not. And there's some terms that go along with it, and that is variables. Variables are the things that we're testing. And there are two types of variables. The independent variable. The independent variable is the factor that we control. We'll spend a little bit more time in class talking about these things and looking at some examples, but this is what we control. This is what we change to see how it affects the experiment. On the next slide, there's a link to a video that we're not going to watch here. You can find that link. Actually, you might have to share that link as well with you. But then you're going to go ahead and take that link and watch that short little clip about Mythbusters, and we're going to look and see if we can tell what the independent and dependent variable are. Then the dependent variable is what factor we see, how does that change in our experiment. Independent, we control. The dependent, we're finding out what it is, how that affects the experiment itself. And those are kind of important things that we look into the graphing aspect. And again, we'll spend a little more time with that as we go along. Finally, we have the control. The control is our comparison. What are we comparing? If we're making a change, how does that affect the experiment? The control is if we don't make any changes. Okay? And as we look at our clip, here's a link. You can actually copy that link, or you can just take that link and type it in and watch that short clip on your own, and then we'll kind of discuss those things a little bit more as we go along. So that will be tomorrow.